Alright, here's a good problem. An object is launched up from ground level and reaches a maximum height of 30 feet. With what initial velocity was it launched? So let's start writing our position model. H of t equals negative, our units are feet, so negative 16 t squared plus v naught t. No plus h naught because it's from ground level, which means its starting height is 0, but I don't know its starting velocity, v naught. I need to find that. So to do this problem, we're going to take the derivative of h of t to get v of t, the velocity, and we'll get negative 32 t plus v naught. And it may look like we have nowhere to go, but we do, because we are told that the object reaches a maximum height of 30 feet. So what I'm going to do is I'm going to write a system of equations. I'm going to say 30 equals negative 16 t squared plus v naught t. That 30 is my maximum height. It's in my height equation right there, which means that t in this equation represents the time that it takes the object to reach its maximum height. So this t now is a specific number. It's not a variable, it's a specific number. And what else do I know about the object when its height is at its maximum value? Well, I know that its instantaneous velocity, v of t, has to equal 0, because when an object's at its max height, its velocity is 0. It is not moving up, it is not moving down, it is momentarily stationary, and it is not moving at all for just the most instantaneous of moments. So 0 equals negative 32t plus v naught. And then again, because I'm plugging in a specific value for v of t, plugging in the value when the velocity is 0, which occurs when the object is at its maximum height, that t represents the time that the object is at its maximum height. So in both of these equations, t equals the same thing. So now I'm going to solve my velocity equation. I'm going to add 32t to both sides to get 32t equals v naught, an expression for my initial velocity in terms of time, which I will plug in to my second equation. 30 equals negative 16t squared plus 32t squared. Because v naught is 32t, that's going there, and then I'm multiplying it by another t, so that will give me t squared. Simplifying, 30 equals negative 16t squared plus positive 32t squared gives me a positive 16t squared. So divide by 16 on both sides. 30 divided by 16 equals t squared. Square root both sides. T will equal the square root of 30 over 16, which is the same as 15 over 8. You don't need to change it, but I like simplifying fractions. So find this value, and notice that here we have an expression for v naught. That's what we ultimately want to find. We want to find the initial velocity, and v naught equals 32 times this t, which we now found to be this expression right here. So if we want v naught, all I need to do is take that time, the square root of 15 over 8, right there, and multiply it by 32. So you can do that all in one step on your calculator, and when you do so, you will get roughly 43.818 if we're rounding, and that would be feet per second as the initial velocity.